Average Schmaverage. Part 1. This statistics capstone takes a closer look at data. The section will help you to understand what an average is. We're going to look at the pros and cons of taking an average at face value. We're going to take a look at skewed graphs, normal curves, and alternatives to the average. And we're also going to compute the median. This first of 3 videos takes a look at understanding what an average is. Now, we're going to start off with 3 teachers, and these 3 teachers all have something different to say about their classes at the end of a semester. They were discussing their final exam scores, and in an effort to reflect over the last semester, they shared their impressions. The first teacher said, "Wow, I had a great class, lots of hard-working students, and only a few low students due to attendance issues." The second teacher said, "Lucky, I had quite the opposite. In fact, most of the class couldn't get it together and there were only a few getting the job done." And finally, the last teacher said, "My students were all over the place. There were no standouts this semester. Okay, maybe a few, but not a lot." From each of the teachers' testimonials, you would expect the classes to have very different averages on the final exam. However, the data tells a different story. Now, let's talk about what an average is. An average represents a balancing point of all the numbers in a data set. There might be many words and symbols used for average, and a common term for an average is mean. Now, on graphing calculators, the symbol X bar is used to calculate the average. In some cases, if the sample size is large enough for the data to be properly vetted, the Greek symbol mu, pronounced M-Y-O-O, mu, is used to indicate the average. Now here's an example. We're going to understand the concept of an average as a balancing point. Now we're going to compute a sample mean from a simple set of data created by looking at some shoe size, looking at the shoe size of a pile of 10 bowling shoes left out after a busy night at the bowling alley. Here are their respective shoe sizes: 2 of them at 6.5, 2 of them at 7, 1 8, 1 9, 1 9.5, and 2 10s. I've arranged this in a set from lowest to highest. Now to find the average, you add up all the numbers in the data set to get a total. So I've taken all of those 10 pair of bowling shoes and I've added them up to get a total of 79.5. Now we take this total and divide it by the number or the amount of numbers that I have in the set. So as I added up all of the shoe sizes, I got a total of 79.5, and there were 10 pairs of shoes, so 79.5 divided by 10 is 7.95. 7.95 is the average of this data set. From the 10 data points collected, we can say that the average shoe size is a little under 8, or 7.95. Now graphically speaking, if we arrange all the points on a dot plot, we can see that the balancing point of this data would be 7.95, and that would be the average of the data. Now if you could take your finger and put this at that exact location, you would actually balance that perfectly, and the x's on one side and the x's on the other would perfectly balance, as if a waiter or waitress is carrying out a large tray of food arranged in this location from the left side to the right. Now, this dot plot was created by making a number line ranged from the least to the greatest data points, and an X was placed on the numerical data for each point. Multiple data points exist where there is more than one instance of that point, as evidenced by 6.5, 7, and 10. You can see how they're stacked on top of each other there. So what we're going to do for this next practice problem is you're going to create a dot plot of this data and place a triangle or balance point at the average. I would like you to try this by yourself a little bit. Please pause the video and make a dot plot from the lowest to the highest number, put X's where they belong, and then before you actually compute the average, what you might want to do is you might want to actually guess where you feel the balancing point is. Then after you've made a guess, compute the average and then put a triangle where the balance point is, like on the previous picture. If you want to see me do the first one, you can let the video roll on and see me do it, but I really would like you to practice it yourself and then check to see by watching the video if you did it correctly. So in making a dot plot, what you should do is plan ahead a little bit. Take a look at the lowest and the highest number. Here's a 2 and here's a 6. So if I put the 2 all the way on the left and the 6 all the way on the right, I have to think, how would I go from 2 to 6? Probably by ones would be appropriate. So 2, 3, 4, 5, and 6. I didn't use up all the space, but that's okay. As long as I use most of it, that would give me a good picture of what I'm about to see. Now I'm going to put an X for the data point that existed at 2. Now there are 2 data points at 3, so I'm going to stack them up like so. 1 data point at 4, 2 data points at 5, and 1 data point at 6. Alright, well what's great about this is finding the balance point is pretty easy. In fact, without actually running the data point or actually running the average, you can pretty much guess that the average is going to be right at 4, because that seems to be the balancing point of the graph. Now what I'm going to do is actually run the actual average. Now there's one of 2 ways you can actually run an average. You can run an average with a normal calculator or a graphing calculator. So a normal calculator would be pretty straightforward. You would type in, just normal calculator would be fine. You could just type in your numbers as you see them. So 2 plus 3 plus 3 plus 4 plus 5 plus 5 plus 6. And you get a total of 28. And then you go 1, 2, 3, 4, 5, 6, 7 data points. 28 divided by 7 gives me the answer of 4. So the average, much like the balancing point that we assumed, was going to be 4 right here. And we can make a little triangle to show that that is where our balancing point is. Now, for those of you with graphing calculators, I'm going to put this up in the screen here like so. I want to show you that there can be a little bit of a trick here, especially with those of you who want to do everything in one swoop. Because, again, you can add 2 plus 3 plus 3 plus 4 plus 5 plus 5 plus 6 and get a total of 28. And then you divide that by 7 and it gives you the answer of 4. But sometimes I see people type in that entire string of data, let me get that back up on the screen, and then go divide by 7 in one long swoop. This is not going to give you the right answer, because just like adhering to the orders of operations, division goes before addition, and what you really want the calculator to do is to add up all the numbers and then divide by 7. Now this answer of 22.857 and so on and so forth, it should have really raised some red flags. There's no way the balancing point between a data set of 2 and 6 could have an average of 22, a number that's way outside the data set. So that should have been maybe one trick to maybe realize that you made a mistake. But if you insist on using a graphing calculator and you want to do this all within one line, you have to use parentheses, because according to order of operations, parentheses will always go first. So having a graphing calculator does have some advantages. However, knowing how to use it could be your biggest advantage of all. Now that I put parentheses around it, the calculator will compute the addition of these 7 values, and then by putting the division of 7 outside the parentheses, the division takes secondary step to the addition inside the parentheses, and this will give you your answer of 4. So what I'd like you to do is I'd like you to take, if you haven't done so already, do the next 2 problems and check to see how I did or how you did compared to the answer that I put up on the video. Okay, I hope you have finished up part B and part C. I will now go through my answers to these 2 problems. I will do so without showing all the work on the calculator. I feel if you need to review the steps, you can go back and watch the previous problem. But adding up all of these numbers gives you 27, and 27 divided by 7, or sorry, 21, excuse me, not 27. 21 divided by 7 gives you an answer of 3. Now, if you were to look at this on the number line, again, working with the number line from start to finish, you would start off with 1 on the left, and you'd think to yourself, I have to go to 11 on the right. So going by ones, but keeping them pretty close to get there. 2, 3, 4, 5, 6, sorry, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here's 11. So I have 3 1s, I have 2 2s, and I have 1 3. 4, 5, 6, 7, 8, 9, 10, and then 1 at 11. Now, this average is at 3. Now, it's kind of odd to see that the average is as far right as it is, but that's because of the 11. That 11 way out there on the data set really off balances this data set, and you would obviously see that this 11 has quite a bit of a drag, because if I didn't have that, the average would be probably more around 1.8 or 1.9 if I just had these 6 data points instead of the 7th outlier. So looking at this data set, we're going to go 1 through 10. So just like before, start with 1, try to get to 10. So use up a little bit of my space here. 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so I've got 1 at 1, 1 at 2, and nothing at 3, 4, 5, 6. I do have 1 at 7, nothing at 8, and 1 at 9, and 3 at 10s. So where do you think the balancing point is? If you actually did the problem already, the balancing point you had found was a little bit more skewed to the right than to the left in this case, because of all the pile up here, the 10s. And the average in this case is going to be 7. Because if I add up all the numbers, 1, 2, 7, 9, and 3 10s, that adds up to a total of 49. Divided by 7 will give you an answer of 7. And that 7 is going to give me my balancing point right there. So if you put your finger there, imagining if this was a physical number line with 7 x's balancing on this line, that would be the balancing point. So it looks like here my average was skewed to the right because you had more data points on the right, and this one was skewed to the left because I had more data points on the left. Now the vocabulary I'm using, which is skewed and outliers, is going to be further explored in the next video of average Schmaverage as we tip the balance in favor of where we see the data. Thank you for watching.